So today's topic is about the vectors. So what we will first the definition of the vector, how we define the term vector. So vector is simply a physical quantity which is having magnitude, unit, as well as direction. So any physical quantity because physical quantities should have some magnitude and unit should be there. But if that quantity, we additional information about that quantity that a direction is there, then what we call that as a vector. So example, if we say an object is there and it experiences a force of 30 Newton and we specify a direction, we say an object experiences a force of 30 Newtons towards right. So what this 30 is representing, this 30 is representing the magnitude, the number, the value. What the Newton is representing, a Newton is representing a unit. It is not necessary that it should be a base unit or it should be uh, it can be a derived unit as well. Like Newton is not the base unit, it is a derived unit. So it should have a magnitude, it should have a unit which can be a base or a derived, and there should be a specific direction. So a physical quantity with a magnitude, unit, as well as direction, how we classify that quantity, we call that as vector. And opposite of the vector, we have scalars. So if I say today's temperature is 42 degrees centigrade, so here the 42 is representing the magnitude, the degree centigrade is representing the unit, but we don't specify a direction. So a physical quantity which has a magnitude, unit, but no direction, what we call that as scalar quantity. So simple definition of a scalar quantity, which is which can be described fully by the magnitude and unit, but we don't specify a direction. And examples like mass of an object, as we say an object is 30 kg or 70 kg, we don't specify a direction. Same thing, the time. If an object takes, say, 2 minutes or 5 minutes to move from one position to another, but we don't specify a direction, we don't say east, west, north, south, upward, downward, right, left, clockwise, or anti clockwise. So, clockwise and anti clockwise are also refers to direction as well. So, if we don't specify a direction, so that's why the time is a scalar. Same way, the volume, the space occupied, we don't mention a specific direction when we express the volume. So volume is also a scalar. So this is introduction of the topic. Today's topic is about the difference between the scalar and the vector, and then the things related to the vectors. These are the learning objective. At the top of the presentation, you can see the learning objective for the Cambridge and the bottom for the edXL. And it's almost same. There is no difference. Now, the first part is addition of the vector. If we want to add a vector or if we want to do addition of the vector, if the two vectors are acting in the same direction and we want to add them, so how we'll add them? We'll simply add their magnitude. Like example, a force of 5 Newton. Here it can be any vector quantity, like it can be force, it can be momentum, it can be velocity, it can be displacement. But if two vectors are acting in the same direction, to find the resultant, what we do, we simply add them. So if the force of 5 Newton and a force of another force 5 Newton, both are acting in the same direction, to find the magnitude, what we do, we just add them. If the two vectors are acting in opposite direction and we want to calculate or find the resultant of the two vectors, so in that case, what we do, we subtract them. So in this case, if we have like 5 meters per second, the velocity, and 5 meter per second, the opposite velocity. So what is the resultant velocity here? It will be plus 5 minus 5, which is equals to 0. Or displacement, you can also say 5 meter towards right, then 5 meter towards left. The net displacement will be 0. So if two vectors are acting in opposite direction, we subtract to find the resultant. If two vectors are acting in the same direction, we add them to find the resultant. Same way, this is also the two vectors are acting in opposite direction. So in that case, how if they have the different magnitudes, then how to work out the resultant? It depends on which one you consider, because even the directions, example, if the right hand side direction I consider as a positive direction, so the left hand side I will consider as a negative direction. So if there is a displacement of 5 meters towards right, and then the object move 10 meters towards left, so what is a net resultant or a net vector is there? So because the 10 is towards left, if right hand side we consider as positive, the left hand side we should consider as negative. Or it can be other way around. The right you can take as negative, the left will be positive. So we have the right hand side we are taking as positive and the left is negative. So it's minus 10 and plus 5. So the resultant vector will be minus 5 meter. What this negative sign is representing? This negative sign is actually representing the position from the starting point. So it means it is 5 meter towards left hand side. So for vectors, if the direction is opposite, one of the vector you have to take as positive and the other vector you will take as negative. So in vector addition, if two vectors are acting in the same direction, you will add them to work out the resultant. If they are acting in opposite directions, you will subtract to work out the resultant. And you have to take the signs, opposite signs. Why you have to take the opposite signs? Because the direction in vectors is represented by the sign. Is it clear? The first part about the addition of the vector. Anyone having a question or doubt till this point? The next part is how to work out the resultant of the vectors. And if you want to add the two vectors, there are different ways we can add the two vectors or we can work out the resultant of the two vectors. Example, we have vector A and we have vector B. This is actually, we use a head to tail rule. So what we do in a head to tail rule, example, we want to find the resultant of A and B. So we'll draw the vectors in the same direction. First, any one of them you can draw first. It does not make difference because A plus B, in terms of vector, A plus B is equals to B plus A. That does not make difference. But A minus B is not equal to B minus A. The subtraction is not same. A minus B and B minus A will give a different result in terms of the direction. But A plus B and B plus A in terms of vector will be same. So when addition of a vector is done, whenever you're adding the two vectors, it does not make difference that any one of them you can draw first. I can draw A first or I can draw B first. So example, I have two vectors A and B and I want A plus B or B plus A. So first I drew B in the same direction. Then this is the tail of the vector, this is the head of the vector which represent the direction. To draw the second vector, we draw the second vector from the head of the first vector in the relative direction. So this is B and this one is A. What about the resultant in terms of the vector? If you want the resultant is always from the tail of the first to the head of the last. So when you join the tail of the first vector to the head of the last vector, you will get the resultant. Right now we are just discussing how to work out the resultant, not the magnitude. How to work out the magnitude of the vector, that is the next part. But right now we are just only discussing how to work out the direction of the resultant. So what will be the direction of the resultant? From tail of the first to the head of the last we join. So this is the tail of the first and this is the head of the last. So when we join, what we get the resultant of these two vectors. And in this case, we have A plus B. So direction of the resultant or A plus B is in this way. Is it clear till this point? Anyone having a doubt or a question? Okay. Now, if we want to subtract the vectors, we want a minus b or b minus a. As I mentioned, a minus b is not equal to b minus a. In terms of the vector, it will be different. So, for example, we have the two vectors like a is given and this one is b is given. And the question is we have to find a minus b. So how it can be done? A minus b. So the vector which is written first, you have to draw that first. Okay. So in this case, first we'll draw a. So we do a. Then what about the next is minus b. So b is in this direction. What will the direction of the negative be? It will be opposite. So when we draw the second vector minus b, so the minus b will point in this way. Same length but opposite direction. Because in terms of vector, as I said, that if b is directed in this way, what is the direction of the minus b? It will be opposite. So if this is given as a b, what will the direction of the negative be? It will be opposite. So if we need a minus b, first we do vector a, then we do vector minus b, negative b. So what is the direction of a negative b? The negative b will be opposite direction of the b, so we draw in this opposite direction. Because if it was b, it will point in this manner. But as it is negative b, so it will point in opposite direction. And how to work out the resultant? So the resultant will be tail of the first to the head of the last. So when we join the tail of the first to the head of the last, that will be the resultant. And in this case, the resultant is a minus b. But what if we need b minus a? So if I need b minus a, so how it can be done? If b minus a means I have to draw b first. So the same question, I have two vectors a and b. So first I have to draw b first. So this will be b. Now, the second one, we have to draw negative a. If a is pointing in this way, what will the direction of the negative a? It will be same length, but opposite direction. So we drew the first vector. Now we'll draw the second vector, which is negative a. And how to work out the resultant? Resultant is always from tail of the first to the head of the last. When we join them, we get the resultant. So in this case, this will be equals to b minus a. So as you can see, a minus b in terms of the vector is not equal to b minus a. A minus b, it was pointing upward, where b minus a is pointing downward. So whenever b minus a or a minus b in terms of vector, it's not equal. But a plus b is equals to b plus a. Is this clear about addition and the subtraction of the vectors using the head to tail rule? That's how we get the relative direction of the vector, of the resultant vector. There was a question like one of the students mentioned that if two vectors a minus b and b minus a, they will have the same magnitude. That's right. But the direction is opposite. So we say that the vectors are opposite. If I say we have initial velocity v1 and we have the final velocity v2. What is the change in the velocity, delta v? How we work out the change in velocity? The difference in the velocity. So how to work out a difference in the velocity or change in velocity? It's v2 minus v1. So in terms of the vector, if I need the change in velocity, how I'll work out? So first, which vector I should draw first? v1 or v2? v1 or v2? v2. Because whenever it's a subtraction, you draw the vector which is given first. So V2 is given first, so I should draw V2 first. So we draw V2 first. That's V2. Then negative V1. If V1 is pointing in this way, what will the direction of negative V1? So it will be in opposite direction, because the negative vector means the direction has changed. So what will the direction of the negative? So we drew the first vector, then we'll draw the second vector, that is equals to negative V1. Now what is the change in the velocity? In this case, the difference in the velocity. So it will be V2 from tail of the first, the first vector we drew, to the head of the last when we draw. That will be the resultant for us. And in this case, the resultant is V2 minus V1. Okay. But if we have, say, two objects have the momentum is denoted by it's the product of mass and velocity. Say an object 1 has a momentum of P1 and object 2 has a momentum of P2. And I want to find the sum of the momentum. I want to find P1 plus P2 in terms of the vectors, because it's addition, so it does not make difference. Any one of them we can draw first. So first we will draw P1, then we draw P2. And to work out the resultant, if you want to work out the resultant, it's always from tail of the first to the head of the last. That will be equals to the resultant. That is P1 plus P2. That's how we work out the relative direction. So finding the magnitude. So it depends on, for example, we can use two ways. What if the both vectors, one of the question is, what if the both vectors added are in the same direction, head to head? So in you mean this question, like example, say this is vector A and this one is vector B. So if you want to find the resultant, is the same way you will work out the resultant. That first you will draw vector A, then you will draw from the head of the first, you will draw vector B. And what is A plus B in this case? So A plus B, from tail of the first to the head of the last, that will be A plus B. So that will be the resultant. And another question, if vector B is in opposite direction. If vector B is in opposite direction, like first we do vector A, okay, and then we do vector B. I will use another color because it will overlap. So say this is vector B, the blue color. So if the vector B is of same length as it's of different length of vector A, how to work out the resultant? So in this case, because B is in this way, if I want to find A minus B, so first I do vector A, then I will do vector minus B. And what about the resultant from tail of the first to the head of the last? That will be the resultant. If the two vectors have the same magnitude but opposite direction, like A and B were having the same magnitude, and I want to find the resultant, so I will draw A first, and then I will draw B. And what about the resultant? Because the starting and the final points are same here. So what is the resultant of A minus B? A minus B is actually equals to 0, because the starting and the final points are same. Is it clear? Okay. Now, if we want to find the magnitude of the vectors, we can use a parallelogram and we can use a triangle method. And in a triangle method, parallelogram is always done with a scale diagram. In a triangle method, if the two vectors are perpendicular or 90-degree, then we have option. We can use a Pythagoras theorem or we can use a scale diagram. Both will give the same result. Or, but because Pythagoras theorem is directly by substituting the values and the ratios, so it will give an exact answer. Scale diagram, there will be a variation. But what if the angle is less than 90 or angle is more than 90? In that case, we'll use only a scale diagram. So if we want to find the magnitude, finding a magnitude, we can use a parallelogram method, we can use a triangle method. If it's in a triangle method, if two vectors are 90, then we have two options. We can use a calculation method or a Pythagoras theorem, or we can also use a scale diagram. Otherwise, if it is less than or greater than 90, then we have to use a scale diagram. Both methods are similar. The only difference is that in a parallelogram method, we start both vectors from a same point. The starting point is same for both vectors. But in a triangle method, the starting points are different for the two vectors. I'll give an example. Say I have two vectors. One is, say I have two vectors. One is 20 meter per second and the other one is 30 meter per second. And I want to find, and its angle is given. Say angle with the x-axis, the horizontal axis given. Take it as 50 and it is 30 meter per second. Now I want to find the resultant of these two vectors using a parallelogram method. In parallelogram method, we first scale because we don't have a ruler or a scale which is 20 meter per second. We are not using a speedometer. We have to convert into length. So what we do, we select a suitable scale which match with the description of the given vector. So example, if I select 1 centimeter is equals to 5 meters per second. That's the scale we selected. So 1 centimeter is 5 meter per second. So it means if we have 20 meter per second, how many centimeters will be there? 4. If we have 30 meters per second, how many centimeters will be there? 6. So we have, first we select a suitable scale for that vector. Now we'll draw the vectors. Any one of the vector you can draw first. Example, we draw 20 meter per second, which is 4 centimeter first. So we drew the first vector, which is 4 centimeter. Okay. Now the second vector is making an angle 50 degrees. So what you have to do, you have to use a protractor. You will place a protractor here. So you will place a protractor here and you will mark where the angle is 50 because we'll read this scale. So this is 0, this one is 10, 20, 30, 40 and 50. So this is 50. So what we do, we'll mark a point where it is 50. And we'll remove the protractor and we'll draw the line. And that line should be 6 centimeter long because 30 meter per second is equals to 6. So this is equals to 6 centimeter long. And the angle between them as we measure, that was 50 degrees. Is it clear till this point? Anyone having a doubt or a question till this point? Okay, so no doubt. Now, how to work out the resultant? So we'll use a compass now. How do we make a scale? Scale, you have to select a suitable scale, because, for example, if one student selected the scale, say example, one student selected the scale that 1 centimeter is 1 meter per second. So 20 centimeter will be 20 meter per second. So that is not the suitable scale, because normally the ruler which you are using, it's about 14 to 15 centimeter long. So your scale, even within 12, 13, it's fine, but not 20 centimeters. So select a suitable scale which can easily be plotted on this or sketch on the result on the paper. Same way, you cannot reduce the scale too much. If one of the students select that 1 centimeter is equals to 10 meter per second, so 20 meter per second will be 2 centimeter. 2 centimeter is a very short length, so it will not be suitable. So after drawing this, what we do? We draw the both vectors from the same point. Now we'll use a compass. We'll use a compass and we open the compass, like example, we open the compass to 4 centimeter. So we open the compass 4 centimeter. After opening it 4 centimeter, we'll place on the other side. Okay. Like I opened 4 centimeter, the compass, and I place on the other side, and then we'll draw an arc. So I will draw an arc. The length of the arc is up to you. Any length you can draw. It can be longer, it can be shorter. That does not make difference. So we open the compass 4 centimeter, we place it on the opposite side and draw an arc. Then we'll remove the compass from here and we open the compass 6 centimeter, the length of this vector. So we open the compass 6 centimeter, we place on the opposite side. Okay. Like we open the compass 6 centimeter, we place it on the opposite side and then we will draw an arc. So we drew an arc. Now we'll mark a point where we drew an arc. So we mark that point and we join the intersection of the two vectors, the starting point of the two vectors, till the intersection of the arc, and that will be our resultant. So this will be the resultant of the two vectors. And we'll measure the length accordingly, like example, using a scale, using a ruler. So using a ruler scale will measure the length, like you place from the beginning. Say we got 10.5. It won't be accurate because I did not scale exactly 4 and 6. But what if it was 10.5? So this is 10.5 centimeter. So 10.5 centimeter equivalent to what? We know 1 centimeter was equals to, the scale was 5 meter per second. So 10.5 meter per centimeters will be equals to x. We just cross multiply. So 10.5 multiplied by 5. So what we got? We will get 52.5 meters per second. It won't be 52.5. Practically, it is incorrect because, like when you are doing with a measurement, I just give an example, the sample calculation. It won't be 50. It cannot be 52.5 as I have only two vectors, 4 and 6. So it will be in the range of 8 centimeter. Is it clear? This one? And we just complete the diagram. We'll complete a parallelogram. So using your scale or a ruler, you join those points and it will complete a parallelogram. So In a parallelogram, what we do, we consider two sides as like two vectors at the sides of the parallelogram, and we complete the vectors accordingly. But if we want to do the same method for a triangle method, if we want to do, the only difference what happen is, first we draw the 4 centimeter. According, after selecting a scale, we draw 4 centimeter, the same example. Then we draw from the 4 centimeter, we will draw 6 centimeter, like the same head to tail rule. So first we do the first vector and we do the second vector. And the second vector was making angle 50. So we'll measure this angle. This angle should be 50 to the horizontal, and say this is 6 centimeter. So we'll place a protector. We'll place a protector here. We place a protector here and we'll mark 50 degrees, like this is a 50 degrees, so we mark 50 degree. And then we'll draw the second vector, which is 6 centimeter. So we do the second vector, which is 6 centimeter. And what about the resultant here? The resultant is always from tail of the first to the head of the last. When we join the tail of the first to the head of the last, that will be our resultant. So only difference between a triangle method and the parallelogram, in a parallelogram, both vectors are starting from the same point, where in a triangle method, we scale first and we use the head to tail rule to draw the first vector, then the second vector, and from tail of the first to the head of the last, that will be the resultant. And at the last, to work out the magnitude of the resultant, what we simply do, we just place a ruler and measure the length of that resultant. So we just measure the length of this resultant accordingly. So measuring a length, and we just write that length. That will be the magnitude of this resultant. Anyone having a doubt or a question till this point?
No, sir.
So the angle between the 4 and, in a triangle method, this angle is not 50. This angle will be different. This will be 180 minus 50. Means this angle will be 130 degrees. Because the total straight line angle is 180. We were having the angle with the horizontal, that was 50. So it means when I drew the first vector, which was 4 centimeter, then I drew the second vector, which was 6 centimeter at an angle of 50. So what will be this angle? This angle will not be 50. This will be 180 minus 50. That is equals to 130. And we join from the tail of the first to the head of the last. That we count as a resultant. So same way, you have to first select the scale. Then in a triangle method, you draw the first vector, then you draw the second vector from tail of the first to the head of the last. But in a parallelogram, both vectors should start from the same point, and you should know the angle between the two vectors. Is it clear? Anyone having a doubt or a question till this point? Any doubt?